Good evening, a very good evening to all of you. I'm so glad you all are here today. We are all excited for this product and to know more about it. We have an expert today. We'll start with the presentation now. So as you see on your screen, the topic for today is Agrocrete, and it is a rare addition in the intensive market of carbon. So let's know more about it. Before we move to Agrocrete, a little about our platform here. So our app, as you know, all Arkihive Connect, many of you might have joined to Instagram, to Facebook, to LinkedIn. Welcome you all. We are basically a platform of exploring materials, connecting with professionals, and discovering opportunities. And meanwhile, we also do a lot of design talks and material talks, just like today. Previously, we have done events on minimalism, interior lighting, earth blocks, agri-bio panels, estimation, lot of other topics. And you can find all about it on our YouTube channel. And you can, if you've missed on all these events, you can always go back and visit these videos on our YouTube channel. So keep following us there. Can we move on to the next slide, please? Okay, yes. So this is me, Samruddhi, your host for today. I will be taking up all the questions, any queries you got regarding this. And of course, yes, Tarun Jami, he's the founder of Green Jams. He himself actually will be the right person to, tell you about his company. He has currently he's doing PhD in civil engineering, if I'm not wrong, and he primarily takes care of the product development and technical operations at Green Jams. So that is a little about him, and he will obviously be talking a lot to you guys. Can we go to the next slide? Yes, a little about what you guys can expect for today is we will be starting with understanding Agrocrete, bio-based building material. Then we will be comparing this product with our other regular products like clay bricks, fly ash bricks, and we will be deep diving into the carbon intensive market and its significance today in the construction industry. We will be talking about its availability, affordability, and by the end, we will talk about the future of this product and future of sustainability. Of course, in between, we have covered all your questions that you have sent to us during your registrations. And apart from that, even on any particular slide, you guys have any questions, please put in your questions in the chat. So by the end of the session, we will be taking all questions. Great to again welcome you all. Please be very active, and I hope you enjoy the session. Over to you, Tarun. Tarun, you're on mute. Yeah.
I'm on mute. Yes, I realized. Thank you so much, Samruddhi, for that introduction. Very, very excited to be here. And also my humblest thanks to all the audience who've joined us today and have lent their ear to listen to what I have to say. So thank you again from the bottom of my heart. At Green Jams, we have a pretty big goal that we're looking to solve. We want to remove 10% of global carbon dioxide emissions, and that's essentially possible just with construction materials. It's pretty baffling. I mean, if everything goes well, I mean, in ideal scenarios, it's actually possible. And that essentially means that you only need 10 such companies or 10 such initiatives to literally bring the world down to net zero. But hey, not everything is ideal. But still, I mean, this is a moonshot goal for us, and we hope to see us achieving it sometime soon. So at Green Jams, we're essentially creating a beautiful and carbon neutral built environment. There's an emphasis on both beautiful and carbon neutral because as a company, while at this current point, we're essentially making building materials. So what we ideally want to do is make these materials so they're friendly for the designers or the architects that they essentially end up creating this beautiful environment, along with best-in-class sustainability, best-in-class thermal insulation, and at the potential opportunity for removing CO2 from the atmosphere. So having said that, I guess we can jump right into the problems that we're solving. Again, as I mentioned, that is the big hairy goal. But when you look at the actual problems that we're solving, it's twofold. About 45% of global carbon emissions come just because of buildings. This is because of most of it essentially. About 39% of global carbon emissions come because of the heating and cooling requirements of the buildings, and another 9% of global CO2 emissions come because of the and manufacturing of construction materials as well as the construction activities. On the other hand, this is an India-specific problem, but not just limited to India. This is a phenomenon that happens all across the world. So in India, we generate about 600 million tons of crop residues, out of which around 100 million tons, get converted into basically upburned, because of which the country loses almost 2 lakh crore rupees in economic losses. But when you look at the world, almost 2 billion tons of crop residues are essentially not are not put to good use. They're essentially discarded, because of which they either turn into CH4, which is methane, or carbon dioxide, or various other greenhouse gas emissions, which eventually create a huge impact on the planet in terms of global warming and climate change and whatnot. So to overcome both problems, we created one solution. We call it Agrocrete. It's a carbon negative, and this is the next slide, by the way. So it's a carbon negative building material made using crop residues and the non-toxic and non-hazardous byproducts from steel and paper manufacturing. So the background of the slide is essentially our own, a shot from our own manufacturing unit in Roorkee, which was made using Agrocrete blocks. I'm going to talk about it in the next slides. So what really is Agrocrete, right? As you can see, it's available in the form of blocks. What we're essentially putting out in the market are these hollow blocks. They have a cavity within, and they're used for both load bearing as well as non-load bearing applications. So primarily, when you look at all of these high-rise constructions and even low-rise constructions these days, because of the heightened awareness, quite a few people are choosing AAC blocks. But then they come with a whole host of disadvantages, right? You have cracks in the walls, you have to treat them well, you have to put these, stupid tie beams after every 4 courses, even though it's a non-load bearing application. So we're essentially overcoming all of those problems at significant advantage. One, the strength is significantly higher than 5 MPa. We consistently achieve 7.5 MPa for a hollow block, which is basically in load-bearing territory. And then we have the load-bearing varieties, which achieve more than 10 MPa in strength. But the biggest advantage is in terms of the U value, right? At 1 watt per meter square Kelvin, we're essentially able to, it's best in class for a 200 mm thick wall. And the embodied carbon is in the negative values, which essentially means that, we're removing CO2 from the atmosphere. And again, the durability is top class, with just 10% water absorption. You don't have dampness in the walls. It does not compromise the structural durability. The aesthetics are fantastic. You won't have dampness, as I mentioned again. We claim a minimum durability of 75 years. But there's nothing which says that this would not last forever. And that's also important because when you're using crop residues, it's essentially an amazing carbon capture method. So because you already have crop residues which have absorbed CO2 from the atmosphere and became that mass, we simply entomb it within this mineral matrix that is with the other ingredients, which I'm going to cover in the next slides. We were able to capture CO2 from the atmosphere. So the extremely long life is actually a fantastic opportunity. And for us, we want it to be linear as a technology, even though we're using recovered materials. But the end of life for Agrocrete essentially should be, safe disposal, where one, it's not occupying a huge amount of land mass, but it's also capturing CO2 and locks it forever. But having said all of that, why does anyone pick Agrocrete over regular building materials? The next slide. This is simply because of the cost. So when you
okay, yeah. Before we move on to the next slide, we're just taking up a question, Tarun. So,
okay,
what are the quality tests of the product for Agrocrete? If you want to talk about this right now, or maybe in the later slides, that should be fine with us.
sure. I mean, I can definitely talk about it right now. So, quality and technical parameters are two different things altogether. So in quality, you're essentially looking at how the construction is done, how the in quality, you're looking at how the manufacturing is done and how you're keeping it consistent so that, you're achieving the same level of, you're achieving the same properties, the same parameters. But, and we're able to achieve that because we use automatic machines where everything is controlled in a factory. Everything is we ensure that the exact amount of raw materials are going into it, and therefore the final product is also the exact same. We've perfected the technology to a point where it doesn't matter what sort of crop residues we're using. We could essentially use paddy straw, bagasse, cotton straw, corn straw, a whole list of crop residues available to us right now. When it comes to the technical parameters, Agrocrete satisfies the requirements of IS 2185. In fact, it surpasses it. We've benchmarked it against IS 2185 Part 2 and Part 3. Part 3 is for AAC blocks, but that's the most relevant standard that is available to us. At this point, we're also benchmarking Agrocrete against certain international standards. It's a product made for the globe in India. So we're essentially looking at BS 5234, ISO 7292, and so on. Right. So that's the customer value proposition. The reason anyone picks up Agrocrete over conventional materials is one, because of the larger block sizes, which translate to lesser number of mortar joints. And because it's a cavity block, the amount of mortar that you apply onto the outermost face shell is significantly lesser than the amount of mortar you would apply to the whole, the surface of a solid block. And again, because of the larger block sizes and easier handling and everything, the amount of labor required to make the wall is actually quite lesser. And all of this translates to the next slide, please. So all of this translates to lower cost of construction, up to 50% actually. And so how is a question, right? So when you look at one clay brick wall, a square meter of it, it would cost around 2,250 rupees. And this includes the cost of the bricks itself, the amount of mortar that you put in, the amount of labor that you require, the higher thickness of plaster that you have to apply. All of these things included, even a base coat of paint, that turns out to be around 2,250 rupees. The same wall, the same thickness, everything with Agrocrete is just 1,250 rupees. So there's almost 50% cheaper. In the future, we're essentially looking at entering the voluntary carbon markets, after which we would essentially be able to, transfer some of those benefits, unlocking this another revenue stream through the voluntary carbon markets. We'd be able to make this even cheaper. And beyond it all, because it's a factory-made product, we're also able to achieve customization in types of the design of the blocks. We're soon introducing interlocking varieties. Essentially, we're also introducing U-type blocks and so on. All of this while being climate positive, because Agrocrete has a negative embodied carbon. The next slide, please. So impact is something that we're very, very passionate about. As you might have already noticed from the beginning of the presentation, the reason that we started this company, the reason that we're still passionate about what we do is simply because of the impact that we're able to drive. For us, it's all about reversing climate change, and you would see that from this the particular slide. So one manufacturing unit, which produces about 900,000 blocks per annum, is sufficient to build only about 300,000 square feet of built-up area. But this one manufacturing unit has a huge impact. So we're able to prevent 3,500 tons of CO2 by replacing your regular burnt clay bricks. But beyond that, we're also able to capture another 1,080 tons of CO2 because of the negative embodied carbon. So one manufacturing unit, single shift operations per day, literally running for just 8 hours a day, the net impact is almost 4,644 tons of CO2 removed. That sort of an emissions would occur if you drive a fuel efficient car along the Earth's circumference 463 times. It's a lot of times and a lot of kilometers. Along the way, we're able to achieve 9 out of 17 UN Sustainable Development Goals. The next, please. Is there a question? Oh, good. All right. So the manufacturing process is actually quite simple. What we do is we first collect the crop residues from the farmers. We chop them up into small particles. And this is where the most critical part of the process takes place. We essentially treat it with hot water. And this is extremely important because especially for something like paddy straw, because it comes with a huge amount of fertilizers, chemicals, and pesticides and whatnot, and also a layer of wax which which inhibits the whole, the setting, the bonding, and everything. So once the crop residues are prepared, we also prepare something called binder in a separate manufacturing unit. This is a proprietary product by Green Gems, simply made because crop residues and regular Portland cement do not go hand in hand. And we also wanted to avoid the impact, the climate impact of cement, which is again very bad. So what we did was we created this amazing ingenious product called binder. It is made from the non-toxic and non-hazardous wastes from steel manufacturing. So what happens is we basically take the crop residues, the binder, and fly ash, basically any kind of fly ash, be it coal ash, bagasse ash. I mean, there are lots of varieties of ash now available in the market coming from various boiler sources. So we combine all of these three together in a patented mix ratio. And then we simply compact it in a regular hydraulic block making machine, and we leave it out for a duration of 7 days. There is no heating, there is no water curing, there is no steam curing, no autoclaving, none of that monstrous steps involved. So everything is taken care of by this patented advanced alkali activation chemical technology, because of which we're able to keep the resource consumption low, we're able to keep the energy consumption low, and we're also able to deliver top class sustainability to our customers. The only downside is that it takes 7 days from the point that it is molded to the time that it can be delivered to our end users. Next slide.
So yeah, next is a question, Tarun, coming up that after now you spoke about manufacturing. So are there any specific construction techniques or skill labor required for this product for laying out this product basically on the site?
Yeah, so not really. You don't need any specific techniques required. These days, every mason knows how to work with a block. In fact, in all the construction projects that we have done until now, the masons that we hired were those who essentially were only working with red bricks, and it took them all of 5 minutes to know how to switch from your regular red brick to Agrocrete blocks. It's a very simple, it's a very scalable and a linear process. You can simply pick up the block and start working with it.
All right. Okay. Next slide.
So we're very fortunate to be working with some of the best construction companies in India. It's interesting that Amazon also made it to the cut, and I'll explain how. So we've already completed the 3 projects. We're working on several others. We have a few villas that we're supplying the blocks to, a few factory buildings that we're supplying the blocks to. In fact, we're in a very, very fortunate space where we've received more than, right now the number is beyond 1,500 block inquiries for blocks. And the total volume is almost 1.2 crore blocks. That's sort of volumes that we are dealing with right now. And that's essentially why we're also ramping up our manufacturing capability extremely fast. we're in fact starting a new manufacturing unit in Meerut. And again, some of the people that we've worked with are CBRE and Shell. They've used our blocks to create a few small support structures. And the biggest motivation for them was the negative carbon footprint of Agrocrete. And right now, blocks are also being evaluated by, as I mentioned, the best construction companies in the country. And Amazon is also looking at evaluating Agrocrete and see if they could essentially use it to build their future warehouses. Anyway, the next slide, please. So this is our first ever Agrocrete building in India. It's 1,100 square feet load bearing structure. There's in fact our own manufacturing unit in Roorkee, where we used almost 2,500 blocks, which helped us capture almost 3.1 tons of CO2. Over here, this was since we were essentially manufacturing the blocks at a very, very small scale. We were able to reduce the cost of construction by 30% and reduce the number of man hours as well as mortar joints by another 60%. So that's essentially why we were able to reduce the cost by 30%. And what's interesting is this building was up and functioning in 7 days flat from the time that we did the first scratch to excavate the land for the foundation to the point that we laid the roof on top. It was just 7 days. That's all it took. The whole structure, the brickwork and everything was completed in 4 days by just 2 masons. There's also a video on this, on how we've done the whole construction. You're more than welcome to visit our website or YouTube, where we've uploaded the video. I'll also be happy to put the link to it in the chat later. Okay, and the next project is...
next, again, we have one more question before we go to your second project. What are the limitations one can face maybe while using Agrocrete? Are there any specific challenges?
So there are actually no challenges. The only things that we basically recommend to anyone in the construction field is to always use gloves and safety equipment when you are building with it. But in fact, it's only advantages that there are with Agrocrete. And the only other downside is during monsoons, if you leave it exposed to the environment, then there is a slight discoloration. So it turns from creamish gray to sort of brown in color.
Okay, if you say that, then it's just a question that then what would be the finishing to this material if we have to avoid this decoloring or something like that?
So there are multiple finishes available, right? Like for example, there is Dr. Fixit's Repellent WR. So that's an amazing brick sealant. So once you've done the whole construction, then you simply apply the sealant on top, and then you can leave it exposed. Alternatively, again, as I mentioned, so sorry, I didn't mention this. We always recommend that the blocks be plastered on the external side. You can always leave it unplastered on the internal side.
Okay, yes. We can move to the next slide.
Cool. So this is the other completed project. This is a load-bearing structure again, 1,500 square feet. So this particular client was already building with red bricks when he discovered us, and then immediately switched to Agrocrete blocks midway. So that essentially also shows that you don't really have to use the same block for the entire building. You can also switch in between. Again, a residential building over here, they were able to reduce the amount of labor and mortar by 60%, and consequently, they also captured 2.36 tons of CO2. The next slide. So these are some of the pictures from the construction site. And I mean, this first photo was also featured on the Better India. Anyway, let's go to the next slide. Is there a question?
Yes, a question about durability of Agrocrete.
Yeah, I already mentioned this right at the first slide, right?
Yeah.
So we claim a life of almost of at least 75 years. There's nothing to show that this will not last forever.
Okay, can we take up a question from the chat? Divya is asking, is it water resistant?
Yeah, of course it is water resistant. I mean, I'd mentioned, right, the water absorption is just 10%. Literally every building material out there is essentially has some sort of an interaction with moisture. It's definitely not waterproof or it's not water repelling, but it is water resistant. There's another question they're asking, what are we using for mortar? We use regular cement mortar. There are no changes there. We also have our own product called Binder, which is essentially made using, I mean, as I mentioned already, made using the non-toxic byproducts from steel manufacturing. All
yes,
right.
Someone wanted to know more about Binder only. That was the first question. Can we know more about Binder?
So more about Binder. I mean, as I mentioned, Binder is this cement alternative made using the byproducts from steel manufacturing, more specifically the slags. And at this current point, we're using it as a masonry cement for making mortar joints and for making mortar and plaster. But going forward, soon we would be introducing it as a structural cementitious material.
Okay, guys, you can put up your questions anymore. We're just looking at the organizations that have supported Green Jam so far. Also, can we move to the next slide, Anusha? Yes, you can just.
Cool. So this is basically the end of the presentation almost. Fortunate to have been recognized by quite a few the organizations, but also received quite a few government grants. The list is.
Can we take up the questions?
Right, yeah, sure.
Okay. So you see, how were the environmental factors considered while manufacturing? After this question, guys, I will update you a little about Arkihive, and then we will take up more questions. I repeat the question, how were the environmental factors considered while manufacturing?
The environmental factors, I mean, we literally looked at everything, right? So we've done a pretty comprehensive life cycle analysis. As Samriddhi had already introduced me, I'm also doing a PhD, which also entails doing life cycle analysis of products. And I've used all of those skills to essentially look at the whole the life cycle of the product. So we've accounted for the scope 2 as well as scope 3 emissions. We've accounted for the amount of so while we collect the crop residues, I mean, there's a fair bit of mechanization, so we've accounted for the emissions coming from there. Once it comes to our manufacturing unit, there's transportation involved. We've accounted for the emissions there, and obviously the whole emissions occurring because of the energy, right from drawing the water to the fuel that we use to heat up the water, to chopping the crop residues, to including things like running the exhaust fan, the fans, and all of those things, the lighting and everything. So it's pretty comprehensive in terms of how we've accounted for the carbon footprint.
We have one more question regarding fire resistant. Is the block fire resistant? Since
the blocks are fire resistant. Yes, I get this question a lot. They're non-flammable, they're fire resisting, and even at 1200 degrees centigrade, they do not go up in flames. There's also a video on our Instagram where I've shot how the Agrocrete behaves at 1200 degrees centigrade using a butane burner.
Tarun, you can maybe leave a link in the chat of the video that you're seeing. Till the time, I will just guide you to Arkihive, guys. So you see the screen right now. This is just an example of how you can find products on our platform. And currently, obviously, the trending product for today is Agrocrete from Green Jams. And this is how our platform will look like, where you will find details about the size details, the quantity. You can mention your quantity and you can directly place a code to Green Jams through us. Also, along with Green Jams, you will find other companies, other relevant companies, and many more trending and sustainable products on our site. So that was about Arkihive. Tarun is dropping a link for the videos. Maybe you can have a look. I'm taking up the next question, Tarun. So as the Agrocrete approaches the end of its lifespan at around 35 years, what are the kind of problems the structure will face and how can they be mitigated?
That's exactly what I was saying. I mean, even though we've claimed a minimum life of around 75 years, that's the minimum life. There's nothing which says that, that it won't last a lifetime. Again, I mean, to essentially answer that particular question, this product will have to be 35 years old, is when, we would essentially know for sure in real life what would happen. But from all the accelerated weathering tests that we have done, in fact, some of the most rigorous testing that we've done on this was 25 cycles of wetting and drying in extremely harsh conditions in the alkaline environments as well as acidic environments. So this involves 24 hours of soaking it in both alkaline and acidic environments and drying it at 120 degrees centigrade in an oven for another 24 hours. And despite 25 cycles, what we saw was 3% increase in strength. So having said that, I mean, to essentially be letting you know on what the changes would be after 35 years, I mean, I think the product has to be out there for 35 years.
Okay. One question is about a weight ratio with respect to red brick. I think you have mentioned that in the sheets, right?
Yeah, in
the
technical comparison I have. So the hollow blocks have a bulk density of around 850. And the red brick is around 1800. So we're looking at almost 50% weight that are for red brick. In terms of AAC blocks, this is slightly more heavy by around 200 kg per meter cube.
Okay. How does how CO2 is being captured? Can you elaborate on how it is being done?
So the mechanism is through the crop residues itself. So I mean, everyone knows when crops grow, it happens through the process called photosynthesis, which means that the plant is absorbing CO2 from the atmosphere, converting it using the power of light and water into various products. Some of it includes things like cellulose and other organic compounds, which form the body of the organism of the plant. So that's essentially what we do. We collect the crop residues and we do not burn it, nor do we subject it to any other process where all of those, the body, I mean, essentially the plant itself is, converted into compounds which again escape into the atmosphere. So that's essentially the carbon capture mechanism. Because we're taking the crop residues and entombing it within a mineral matrix that acts. I mean, that essentially is the pathway for carbon capture.
Okay. Next is about how about at joints, 100% crack resistant, or will there be any? Will it face any thermal cracks?
So, I mean, both the buildings right now are a year old. They've been subjected to one summer, one monsoon, and one winter. We haven't seen any cracks on the walls until now, even in load-bearing conditions.
Okay. Komal is asking about number of floors that can be constructed using Agrocrete. I think there is no limitation, as you said, but if you want to just address it again.
No, you said it. There's no limitation. So the hollow blocks are best suited for high-rise constructions. I mean, you can go how many floors as you want. If you want to do a load-bearing construction, then you'll have to talk to a structural engineer who will then design it accordingly.
All right. One question from Ratish. Till what temperature does the brick resist the fire or heat?
Like I said, at 1200 degrees centigrade under a butane burner's flame, it did not disintegrate.
All right.
So I mean, like obviously, I mean, if I were to push it to 1400 or 1500, then it would definitely turn into. Or if I were to sustain the 1200 degrees centigrade for say around 3 hours or maybe 6 hours, is when it would start turning into something else. Okay. Again, it does not ever go up in flames.
Vicky is elaborating on the weight of the block, approximately weight of one block would be.
So it depends on the size. Our 6-inch block, which has dimensions of 16 inches by 6 inches by 6 inches, is about 6 kilos. So that is equal to almost the weight of almost 2 red bricks. But then in terms of volume, it is covering about 5.5 red bricks.
Okay. Rohan has a question for you. What is the costing per block or per square feet?
Like I said, it depends, right, on the size, the thickness of the wall and everything. Again, giving you the same 6-inch example, 1 square feet of wall comes out to be including everything. The block, the mortar, the labor, even the plaster included comes out to be around 78, 79, somewhere close to 80.
Okay. Few of them are asking you about dealers in Maharashtra, or is it available in Tamil Nadu, etc. Can you guide about that?
Nope, nothing in Tamil Nadu or Maharashtra at this point. Maharashtra has been extremely kind to us. We're actually looking at setting up a mega factory for Agrocrete in the near future.
Okay. And Divya wants to know, where is it available right now? I think you have right on the screen, you have contact details of Green Jams as well as Arkihive, Divya. So you can directly get in touch with either us as well as Green Jams. Okay, guys, you can put up more questions for another 5 minutes. We're here to answer you. Otherwise, you have our contact details on your screen, and I've also dropped you links about our app. So we are a platform where you can, understand materials, buy materials, have some business opportunities with us. And we are very fortunate that we are now associating with these brands like Green Jams. So do reach out to us for any more queries about this product as well as to know other products. Thank you so much, guys, for joining. Thank you, Tarun. A big thanks to you for being here with us and giving us such an information and insightful presentation. Thank you very much.
Thank you, Rohan. Thank you, Samruddhi. Thank you all for coming. Rohan had a kind word to say, so that's
great. Thanks. Thank you so much, Rohan. Yes. Thank you, guys.